A piecewise function is a function made up of multiple equations, all defined over specific domains. So for example, f of x is equal to x squared, where -3 is less than x, which is less than or equal to 1. X plus 5 is equal, where x is greater than 1. So these pieces here are known as your domains. And these pieces here are your rules or your functions. To evaluate a piecewise function, determine the domain that the input belongs to and use that equation or rule to simplify. To graph a piecewise function, you're going to graph each piece over their respective domain on the graph and make sure to pay attention to the endpoints of each piece. So if it's one of these, it's going to get a closed circle. If it's one of these, it's going to get an open circle. And if it's two specific endpoints, obviously one is a closed, one is an open. If there's no other endpoint, it's going to get an arrow. So let's take a look at some of these. We're going to start with evaluating algebraically. So once again, these are my domains, and these are my rules. So find f of -4. Remember that this is my input. So this is x equals -4. So I want to locate the domain where -4 belongs. So my domain for -4 is here. X is less than or equal to -2. -4 falls in here. It's less than or equal to -2. So this is the rule that I'm going to use. So 2x plus 8 is what I'm going to substitute into. 2 times -4 plus 8, -8 plus 8. So f of -4 is 0. Let's go to the next one. They want us to find f of 6. So I first need to identify the domain where 6 falls. So that would be down here. For x greater than 3, 6 is greater than 3. So I'm going to use the radical x plus 3 rule. So radical 6 plus 3 gives me radical 9, which is 3. So that means f of 6 is 3. The next one, f of -2. So I need to identify the domain. Notice how here -2 falls here and here. But f of -2 has to be where it's equal to -2. In my first line is where it is less than or equal to -2. This one here is just less than, not equal to. So I'm going to use the first rule. So I'm going to use the 2x plus 8 rule. So 2 times -2 plus 8, -4 plus 8. That means that f of -2 is 4. And then lastly, we want f of 0. So finding my domain here, 0 falls in this one. 0 is between -2 and 3. So I am going to use the x squared minus 3 rule. So 0 squared minus 3 is 0 minus 3. That means that f of 0 is equal to -3. So always identify your domain and then substitute in to the corresponding rule to find your output. Here is an example of evaluating graphically. These are easier. Inside the parentheses is still my input. So this is x equals 2. So at x equals 2, where is my graph defined? Right here, -1. X equals -3. So notice here at -3, there are two pieces. But remember that a closed circle is equal to or included or defined. Open circle is does not equal. So I'm always going to choose the closed circle when evaluating. So that means that f of negative 3 is equal to 2.5 because it's in between. F of negative 1, here once again I have two different pieces because this is x equals negative 1, but notice this time that they are both open circles. So because they're both open circles, there's no answer or undefined. F of negative 4 right here, that value is 2. Lastly, let's take a look at how to graph. So when we are graphing, I'm going to graph each piece separately. My first piece is negative 2x plus 1, where x is less than 0. So I'm going to make a table for myself if I was using a calculator, but we're going to do it without a calculator as well. So x is less than 0. So the numbers in the table have to be less than or equal to 0. So that means I'm going to include numbers like negative 5, negative 4, negative 3, negative 2, and so on. You always want to include that last piece, even though it's not defined here. It says x is less than 0, but that's going to be my open circle. So I need to know where to include that open circle. So you can use the slope-intercept method if you want, or you can substitute. Negative 3 goes in for x. So negative 2 times negative 3 is 6. 6 plus 1 is 7. Negative 2 times negative 2 is 4. 4 plus 1 is 5. Negative 2 times negative 1 is 2. 2 plus 1 is 3. Negative 2 times 0 plus 1, 1. So like I said, if you wanted to use slope-intercept, you could plot out 0, 1 is my y-intercept, and I'm going to be having a slope of negative 2, so it should look like this. Now, whoops, I miscounted. Should look like this. So I have an open circle on this endpoint, and there's nothing on this endpoint, so there should be an arrow. Then I'm going to go to my next piece. So I have 2/3 x minus 3, where x is greater than or equal to 0. So first, my domain, x is greater than or equal to 0. So this is going to be numbers like 0, 1, 2, 3, 4, and so on. Always start here. In this case, it's going to be a closed circle. Now, this is one where there's lots of fractions involved, so it's probably easier to follow your slope-intercept method, where I have a y-intercept of negative 3 and a slope of 2/3. So negative 3 up 2 over 3 up 2 over 3 up 2 over 3. Connect, form an arrow. And this, of course, is f of x. Here's my piecewise function. One thing that you should check is that your piecewise, if it's a function, piecewise functions will never crisscross each other because it wouldn't pass the vertical line test. You should never have two closed circles defined directly on top of each other because it also wouldn't pass the vertical line test. So just some quick things to spot check. Does it make sense? Is it a plausible answer?